Hello. Good morning, sir. Am I audible? Yes, sir. Yes, sir. Sir, are the slides visible? The first slide? Sure, sir. Okay. Sure. Yes, sir. Sure, sure, sir.
Welcome back. The third day, second session to be held is on the topic IoT in 5G wireless communication by Dr. Amrita Mishra, Triple IT Bangalore. Now I would request Soumya to introduce our resource person to the gathering.
A warm good morning to everyone. It's my immense pleasure to introduce our research person, Dr. Amrita Mishra. Ma'am has received BTech degree in Electronic and Communication Engineering from Amrita School of Engineering, Amrita Vishwa Vidyapita, Coimbatore, India in 2011, and MTech PhD dual degree with Department of Electrical Engineering, IIT Kanpur, Uttar Pradesh in 2018. Ma'am is currently a faculty member at International Institute of Information Technology, Bangalore. Ma'am research interest includes application of signal processing and machine learning for 5G and beyond, millimeter wave communication for IG and beyond, intelligent reflecting surface, etc. Ma'am was awarded gold medal for securing first rank at university level in BTech programming in electronics and communication engineering, and ma'am achievements are many more. With this brief introduction, I present Dr. Amrita Mishra. Thank you.
Thank you for the very kind and generous introduction. So we'll get started with today's talk. The title of the talk is IoT in 5G wireless communication. So we are going to discuss briefly about the motivation, challenges, and some problem statements around this particular area of IoT in 5G. So this is a brief background. Also, it has been covered very generously in my introduction. So currently, I'm working as an assistant professor at IIT Bangalore, and I have completed my masters and PhD from Indian Institute of Technology, Kanpur. And predominantly, I work on communication systems and applications of machine learning and signal processing in communication. This is a list of some of my sponsored projects, and currently we are again working on building some prototypes, some proof of concepts for modern technologies such as intelligent reflecting surface, 5G ORAN based, MIMO based station, etc. etc. Some of my recent publications. So now going to the most fundamental question which this talk should be able to help us answer is, what is 5G? When we say 5G, what do we mean by it? So if you could see the diagram on my right, every decade since 1980, there has been a progression, a leap in terms of the mobile communication technology. So with the first generation only focusing on mobile voice calls, slowly with every decade, the requirements from the users in terms of integrating more diverse services rather than just restricting a mobile phone to be able to only transmit and receive voice signals has led to the development of the mobile communication technology. So as we can see and as we speak, 5G is already being deployed. So what is 5G all about? Now to put it very simply, fifth generation devices are actually going to run on more or less similar radio frequencies that are currently being used to connect our smartphones, our Wi-Fi networks, but it actually enables technology to go a lot further. What do we mean by a lot further is what this particular presentation is going to talk about. To give a very simple example, if we are present in a crowded stadium, you should be able to, or 5G should enable you as an end user to be able to download a full length high definition movie in a matter of seconds. So there are a lot of critical aspects in terms of requirements which is involved in this particular very toy example, and we are going to discuss and deliberate on them subsequently. So 5G is really about connecting things everywhere. Not just connecting, but connecting them reliably with a very low latency so that people will be able to measure, understand and manage things in real time. So this is the 8 specification requirements which the 3GPP standard releases for 5G technology mandates. So first we require a very high data rate requirement up to 10 gigabits per second, which is roughly about 10 to 100 times more than what the 4G, LTE or 4.5G networks, the just previous generation service providers could offer. Along with that, we mandate or 5G mandates that there should be a latency, a delay as low as of the order of 1 millisecond. Apart from having very high data rates and low latency, 5G requires that the availability of the service or the network should be there almost 99.99% time. 100% coverage in terms of almost negligible call drops. We also talk about energy conservation in 5G, which wasn't something which again the previous generation mobile technology or communication technology focused on. But in 5G and onwards, we are also looking at how can we reduce the energy consumption, and the reason being that we want to connect almost all the devices, which includes the extremely low power IoT devices scattered in very diverse regions which should have a very high battery life. The number of devices which can be connected using 5G should be almost 100 times more than what the previous generation 4G LTE's technology could connect. So to put some numbers, these are the KPIs or key performance indicators of 5G with the peak data rate requirement of 20 gigabits per second in the downlink. Downlink means from the base station to the mobile equipment or the end user, and a 10 gigabits per second in the uplink. Uplink essentially corresponds to the other way around, that is from the user equipment to the base station. Like that, there are several parameters and we have some quantitative numbers associated with it. Now 5G essentially has 3 main verticals, which is again summarized in this category column. One vertical is the EMBB, or one use case is the EMBB. EMBB stands for Enhanced Mobile Broadband, which has a very high data rate requirement. The other use case, certain kind of applications would fall under the vertical of URLLC, which is ultra reliable, low latency communication. And the third vertical is MMTC, which is massive machine type communication, wherein we are talking about at least tens of millions of devices being connected. So massive connectivity is what we are talking. Now to motivate what is 5G capable of, or how is it different from the other or the predecessor mobile technologies, let us look at a couple of deliverables in terms of how can it affect us. So we believe that 5G is not just going to restrict itself to a service provider and the end user kind of a deliverable. It should also be able to advance societies. As a technology, we feel that 5G will be able to open ways for improving safety and sustainability. Sustainability because of the talks or the improvisations with respect to energy consumption is where we should be able to have better sustainability. For example, smarter electricity grids are a great example in being able to reduce the carbon footprint. We also talk about autonomous vehicles, driverless cars, wherein connected vehicles can be sharing their data in order to prevent road accidents, faster deployment of emergency services to places where accidents have occurred. How can this be done? When the fact that an accident has occurred, that communication goes to, say, a centralized place, the dissemination of these kind of emergency services can be done very rapidly. Then we talk about connected sensors which will be able to detect and warn of natural disaster early, and a lot of other examples. For example, UAV, unmanned aerial vehicles or drones, we are talking about that in 5G, which should become a key tool enabled to accelerate and support emergency situation response. Then we are also talking about remote assistance or remote expertise with the help of specialists in both healthcare as well as education. What? Changing the way telemedicine or tele-education is happening. Now 5G is going to also get deployed in industries. What we talk about is Industry 4.2. So it is going to be the foundation of flexible, efficient and responsible business. How will it be a game changer in industries? It will be able to automate the production lines. It should be able to autonomously route goods based on the real world conditions. So the logistics, the deliveries all becomes more efficient and more reliable. Traceability in terms of an individual item to its warehouse, that kind of a visibility with the help of the support, the technology support which 5G offers, we should be able to get. And along or in conjunction with robotics, we should be able to provide some kind of remote access or remote assistance. And in smart agriculture with the help of IoT, we should be able to also use 5G for making crop yields better. So we talked about how 5G is going to touch our lives in a societal perspective, in an industrial perspective. But what sets it apart from the previous or the predecessor generations of mobile technology is it will be able to elevate or enrich our experiences. What do we mean by this? So 5G is actually going to plant the seed for much more immersive entertainment and engaging education. With the help of services such as virtual reality, augmented reality, extended reality, we will be able to deliver sensory experiences like touch through devices. Now, all these applications are extremely high data rate demanding applications, also which require very low latency. That is why 5G is the one which should be able to support such kind of immersive applications, which can be used for teaching, which can be used for conducting meetings, which can be used in entertainment as well. Now, this is some kind of a stage setting which we did for 5G. Now we are going to talk about few basics of IoT, which I'm very sure you would have uh, heard throughout the FDP. But let me just introduce it, and probably we will move on to how the combination of 5G and IoT works. So IoT stands for Internet of Things. It is basically the concept of connecting any device, even if it can be the most basic on-off switch, to internet and to other connected devices. So I find this particular definition of IoT actually the most meaningful, which says that IoT is the big umbrella under which any device belonging to any person placed on any location of the earth, can be a part of any business, any network, should all be connected under one big umbrella all through the planet. So it is nothing but a giant network of connected things and people, all of which, now what is the purpose? Is to collect and share data about the way they are used and about the environment around So essentially we have devices which are placed or scattered all throughout, which have some inherent capabilities of collecting data about what? About the environment they are in and sharing all of this data. So what kind of devices we talk about? As I said, it can be the most simplest of simple devices such as an on-off switch. So it can start from our daily use devices in kitchens, maybe smart microwaves, to the ones which we use almost every day, our wearables, fitness devices, and can go as complex as self-driving cars. So the range of devices which can qualify as an IoT device can be as simple as a switch and as complex as a self-driving car. Now, why is IoT so important? This market is actually booming and is going to increase up to $1,000 billion industry by 2026. And the prediction is that we should be able to have 41 billion IoT devices connected to internet by 2025. So, some examples of IoT use cases is in precision agriculture or smart agriculture, in construction and mining, in digitized education, healthcare, retail, manufacturing, smart city, etc. etc. So, it has the power to become a $13 trillion industry by 2035. Now, very simply put, how does the Internet of Things network or how does an IoT network work? What are the basic components in it? Now, it can be classified to comprise of four distinct components. The first one is the sensor of the device, which collects data from the environment. It can be as simple as a temperature pressure reading to as complex as a full high definition video feed. The second component is connectivity. So these sensors or devices should be connected to cloud or internet through a variety of methods, which can include some kind of a cellular framework, a satellite connection, a Wi-Fi connection, can be as simple as a Bluetooth connection, or the LP WAN connection, or directly connected to internet via the internet. So this is the connectivity aspect. Now once all of the information from various IoT devices comes onto the cloud, what do we do with it? We of course need to do some kind of a data processing or data analysis. The software performs some kind of processing on the data to make or get some meaningful patterns out of it. And finally, the user interface, wherein after the analysis or processing of the data is done, the information which is useful is sent to the end user in some way. Again, it can be a simple alert via a text or a notification. So we need to have a user interface which will proactively allow them to understand what the data is and take some necessary action. So four stages or four components, starting with the IoT sensors and the end user interface, wherein the data, the analyzed data is presented to the user and some necessary reactive action can be taken based on it. Now, what is a broad classification of IoT systems or IoT networks? It can be classified depending upon its use case or its application into four types. One is massive IoT. So, massive IoT, as the name suggests, is basically deployment of IoT devices on a very, very large scale. So, we need to have devices which are low cost, low energy, and handle typically small volumes of data. Massive deployment and coverage has to be large. The other category of IoT systems is critical IoT. Again, as the name suggests, we require it for critical applications, maybe for robotic surgeries on the factory floor, wherein some kind of an assembly of a very precision level needs to be taken. So the requirements for critical IoT would be ultra low latency, ultra reliable data delivery and availability. The third category is broadband IoT, which requires high throughput, high data rates and large data volumes, and with respect to low latency, a best effort kind of a service, because we put more focus on high throughput or high data rates. The last category is the industrial IoT, which requires some kind of a time sensitivity, requires compliance with industrial protocols and synchronization between the various devices, because the kind of assembly work or assembly line wherein things are probably getting manufactured, synchronization between different parts of the assembly line is very much required. Another way to classify IoT networks is what is the backbone of the connectivity which we talked about in the previous slide. So we can have the IoT sensors being connected via part of a cellular network, which again has two other classification, the LTE-M or the narrowband IoT cellular networks. Then the devices may be connected as a part of wide area network or metropolitan area network, WAN or MAN, using Sigfox or LoRaWAN, which are proprietary IoT based technologies, can be a part of a smaller network like a local area network or a personal area network, wherein we can coexist with the Wi-Fi and the Bluetooth technologies. Then I had some use cases of IoT. I'm not going to talk about them in detail. I'm very sure that other resource persons would have definitely covered all of it. So we just talked about IoT in healthcare. How is it going to be a game changer? The first point is very important, end-to-end connectivity, wherein we should be able to handle all of the aspects right from the starting of a patient getting into a hospital until he or she is discharged. All of it should be able to be handled on a IoT level. So it can enable machine to machine communication, interoperability, movement of data say between different departments, some kind of a predictive analysis which can also be incorporated. For example, some analysis based on patients who have come in the past with similar case history, what happened to them, how do we use that information maybe to predict something with the current patient. And the last one is what we talked about, that is the telemedicine or the remote support. Once the patient has been discharged, there should be a way to be able to monitor him or her remotely and take some kind of an emergent action in case of a necessity. Smart home, which will comprise of all kind of devices which we can think of, all appliances, security cameras. We should be able to automate most of the things, starting from pet care, starting from watering our lawns, monitoring the homes remotely, some home automation in terms of switching on and off devices remotely. And I think most of these aspects are already in use as we speak. Then in smart cities, which is of course at a larger scale and will comprise of different aspects. One aspect is the smart grid aspect, wherein we'll have a very efficient energy management system to be able to control the energy use. And then we will have some kind of a smart waste management system, some kind of a smart lighting system, so on and so forth. These are some other applications or use cases of IoT, which this particular diagram here is basically what we use today in our daily lives. Is we have all these wearables and fitness devices, integrating IoT with the education system, in retail, in entertainment and in industries. Now coming to the question, why will the combination of 5G and IoT work? What is it? What are the common aspects and why this fusion is from the positioning, interoperability, new models, key use cases, saving and mobility. Some examples of technology actually to be in 5G to some database latency. So looking more capable into communication services, more into devices and with what kinds of use cases of IoT is also really work together to create visions of opportunities to realize different set of diverse applications. Promises a more friendly ecosystem. So the three main verticals of 5G ecosystem EB and UIC requirements. Development will developers to leverage 5G technology for IoT solution design. Make So what is the vision of 5G IoT is we should be able to have a data rate to the tune of gigabits per second in real-time networks. Low latency should be 10 times smaller in comparison to the LTE networks. Very high bandwidth and spectrum efficiency. Now with 5G technologies such as millimeter wave, massive MIMO, ultra massive MIMO, we can actually realize high bandwidth and spectrum efficiency. Low cost, why? Because IoT should feature in many of its use cases low cost sensors and devices. So the deployment cost should be low. Connected devices, the number of connected devices should be high, which is expected to go as high as 80 billion. Longer battery life, which goes in sync with the energy conservation aspect of 5G technology and reducing the energy consumption by almost 90%. So the reduction of energy in 5G technologies can be achieved by deploying what we call green technologies, and this in turn can be helpful for massive connectivity in IoT platforms and very high data rates. So this is a very simplistic depiction of the architectural view of 5G IoT. So what we have at the bottom is the sensors layer, which comprises of a large variety of sensors or devices. Then we have a IoT gateway, which is synonymous to the network layer, and there is a 5G link which connects it to the communication layer, which can be simply a base station, which further connects it to the architecture layer. Essentially, the cloud storage, the intelligence and the analytics aspects will be taken care in the architecture layer, and the one wherein we are able to provide a user interface platform for the end user to see, understand the analysis and take some necessary action is basically the applications layer. Now the sensors layer will be combination of the sensors and the interfacing unit with the environment. It should be capable of two-way communication, both back and forth. And the smart sensors will have numerous advantage over conventional sensors, which conventional IoT networks have. Because with the help of 5G, we should be able to enable smart communication between devices, sensors, network protocols, less cable or wired communication. Maintenance installations should be easier. They should be low cost and low power consuming, should be able to have better reliability performance. Then we are talking about the network layer, wherein the requirement is to be able to provide low power and long range connectivity. In this particular aspect, this table summarizes the various technologies which the IoT LTE networks use, starting from Sigfox, LoRaWAN, Zigbee, Wi-Fi, narrowband IoT, so on and so forth, which have different frequency bands of usage, different ranges, and different other metrics in terms of the peak data rate, the bandwidth utilization, the modulation support, and what kind of standardization do they form. So multiple connections are possible to achieve massive IoT and critical IoT connectivity through low powered WANs. So LPWAN technology is mainly used in the IoT applications because of its unique feature of wider area coverage and low power consumption. Now, the communication layer is where we think that the 5G can use the radio access technology for IoT applications. Now, the current 5G NR stands for New Radio, is operational in both the sub-6 gigahertz band or the spectrum and the higher spectrum, which is almost in the range of 20 to 100 gigahertz. Theoretically speaking, the upper limit should be 300 gigahertz, but 20 to 100 gigahertz is what is being practically used. And a variety of complex technologies such as NR supported IoT, massive MIMO, waveform design, frame structure, coding, millimeter wave frequencies can be considered. Now, there are two main aspects of 5G NR. One is the waveform design and frame structure. Second one is the utility of the physical infrastructure using massive MIMO and millimeter wave technology. Now, architecture layer, where we have the cloud platform. The cloud-based architecture is preferred. Why? Because it is the most trending one and state-of-the-art currently being used, mainly associated with various kinds of IT services and can be readily extended with the help of the embedded system programming. Now, client technology in IoT is in fact the architecture for all kinds of ubiquitous services that can be delivered to the users with minimum service management. And we can have internet-based computing where services where large cloud servers, data storage units can be utilized in order to provide some kind of a security or privacy such as authentication through the cloud internet. And finally, the application layer, which is basically the end user, wherein we can have various kinds of applications such as smart cities, smart homes, e-healthcare, smart transportation, so on. Now, the last aspect where I'm going to talk about, so we discussed what is 5G, we discussed what is IoT, we discussed why this combination of 5G and IoT will work. So now let us talk about some of the challenges of combining 5G and IoT and future directions, which is essentially our open resource research problems inside. So 5G IoT should be able to enable massive connectivity. So 5G and 6G networks are expected to support 10 to the power 6 and 10 to the power 7 devices per kilometer square respectively. So big percentage of the new connections will be due to massive IoT applications, that is the MMTC use case of 5G. Now, MMTC devices have very limited power while they may need to reach a very far base station. For example, if we consider smart agriculture, the sensors might be deployed in various portions of a field, and they should be able to sense maybe some kind of soil characteristics and send back the information to a base station. So this is one of the challenge of having massive connectivity in IoT. So the solutions, potential solutions to solve this problem is we change the spectrum, or we move to the unutilized spectrum bands or frequency bands such as millimeter or terahertz. We make the connections, or what we call in communication the access technologies, different than the traditional ones, such as what has been used up to 4G and LTE is the OFDMA, orthogonal frequency division multiple access technology. But now we want to use better technologies than that, better in the sense more efficient in being able to support a massive number of users or service users. So multiple access technologies such as NOMA, which stands for non-orthogonal multiple access. Again, it has various types. One can be power domain, one can be core domain. The third category of solution is the random access based control, wherein you should be able to have some kind of a grant free random access or unsourced random access. So here random access refers to access of the resource block, which would essentially be either time or frequency. Then the second potential challenge in 5G IoT is the security aspect. Now, most types of existing communication standards in IoT, such as narrowband IoT, LoRaWAN, Sigfox, are not designed with end-to-end security in mind. So, as we speak, 98% of IoT traffic is actually unencrypted, wherein all the traffic should be encrypted. When we talk about use cases such as smart healthcare, so very confidential information about the patients, when we say that we want end-to-end connectivity, that kind of a security should be provided to handle all such sensitive data. So this is the overview of the devices and communication links for a typical IoT deployment. So group A category of devices are the general sensors of the devices, such as a cell phone, maybe a car with a sensor or a bicycle with a sensor, which relays information to a cellular base station gateway, and that further on sends the information to a server or a cloud, which finally does the analysis and sends it to the client or the client application. Now, there are three aspects, or the information security has three corners as we speak. One is the availability of the service, confidentiality of or security of the data, and the third word is integrity or authentication of who has access to the data. So, all these three aspects should be supported when we talk about using IoT, 5G and IoT for critical applications which requires handling sensitive data. Now, limited battery lifetime. Now, all of us know that IoT sensors, ideally speaking, should be extremely low power consuming. Why? Because they have very limited battery lifetime, and they are going to be placed in very remote locations, which means that we cannot change the battery associated with these devices very frequently. So narrowband IoT technology, which is currently the state of the art, has significantly improved the battery lifetime of IoT devices in comparison to LTE. However, there still exists a gap between the 5G expectations and the expected battery lifetime in narrowband IoT networks. So some potential directions in making or extending the battery lifetime would be: one is relaxing the resource reservation procedure for short packet IoT communications. That is what we call as grant-free radio access, wherein you are able to go and grab the resource block before any control signaling is done, that potentially helps you in saving the energy also. Ultra low power wake up receiver for IoT devices, wherein there should be some protocols or mechanisms in place such that these IoT devices, when they wake up from their sleep cycle, they will actually consume very less power. In fact, this waking up is where a major chunk of the power consumption goes. And the third one, very interestingly, we are discussing is wireless energy transfer to IoT devices and energy harvesting from environment, wherein we are saying that from the environment we should be able to harvest energy and further extend our battery life. Now, when we said that we want 5G and IoT to work together, 5G is going to use the millimeter wave frequency band, which essentially is the spectrum from 22 or 30 to 300 gigahertz. So, current millimeter wave access points are actually equipped with phased arrays, which mean a large number of small antennas which are packed very closely with respect to each other, and they can only illuminate. The way these phased arrays work is they can only throw one beam at a time, which actually creates a large delay for serving multiple users in a network system, wherein the users are spatially spread and cannot be served by the same beam. So this creates some kind of loss in efficiency. However, if we consider dynamic IoT systems, for example, a factory floor, now tracking the best beam to serve each user might incur or might be a very tedious and a time consuming task. So there is definitely for this particular problem a clear trade-off between gain of narrow beams and ease of rapidity by selecting wider beams. So the takeaway from this particular slide is, in the way the current 5G technologies work, the protocols are designed, may not be directly compatible with the requirements for IoT applications. So we need to do some kind of a matchmaking. In this particular example, need to jointly optimize the beam design and beam selection according to the network, dynamics of the network and dynamics of the traffic, which essentially means that depending upon the particular IoT application, we need to go back and revisit certain basics of the 5G associated communication technology. The next challenge is the network device cooperation, wherein we are talking about adaptive network device cooperative schemes, particularly for the URLLC use cases. For example, for low latency multi-hop transmission, relays are traditionally used to extend range, but typical relays will again incur a delay due to the processing aspect. So 5G IoT requires development of relaying techniques with some kind of a less processing overhead. The third part is distributed cooperative transmission. So here, instead of having one controller, one central unit, you will have every device working in a distributed but in a cooperative manner to enable fast and reliable cooperative relaying. Another challenge is designing the suitable channel coding and decoding scheme. So future wireless systems should be able to provide service to various applications for a diverse range of requirements. For IoT, these can vary from high reliability and low latency to extreme low energy consumption and deep or vast coverage. So accordingly, the channel coding techniques need to be designed for meeting these requirements. So what is the future? If we could summarize the vision of 6G as in the document of IMT 2030, it is going to have a 3D coverage which is going to be across terrestrial, UAV, satellite and maritime networks. It is going to be data driven in the sense it is going to help us analyze from the large or colossal amount of data which surrounds us. We should be able to make sense of it. So it is going to have AI integrated. is going to use possibly all frequencies starting from the conventional sub 6 gigahertz, the millimeter wave which currently 5G uses, the upcoming terahertz frequency band which is again still completely unutilized but has its own set of challenges because of the extremely high frequency of operation, optical bands, and is also going to be IoT dominant in the sense all the four kinds or categories of IoT networks are going to be quite prevalent in 6G. So this is a very well known diagram wherein we have the key performance specification is what is defined requirements of 5G, which was pronounced in the IMT 2020, and the outer one is what is defining the requirements of the upcoming 6G. So key takeaways for future is 6G is definitely going to be IoT dominant and will bring in a new concept of Internet of Senses or IOS, which will allow us to have digital sensory experiences such as touch, smell, taste, similar to the ones we experience in our physical world. 6G IoT may include use cases that are not captured by the 5G classification of IoT either into MMTC or into URLLC or into EMB. So we might have some different new use cases. For example, one prediction is the age of information or information freshness. How fresh the information is actually a more relevant measure than latency, which is the main concern in URLLC. So with this, I would like to end my presentation and I'm open to take any questions from the audience. Thank you so much.
Hello, madam. Can you hear me? It's good afternoon. Can you hear me?
Yes, ma'am.
Huh. In 5G, in comparison with other communication, what about the latency?
The latency is actually going is as we speak. The requirement is at least 10 milliseconds and could be reduced to the maximum possible extent up to 1 millisecond. 1 millisecond is the ideal latency requirement of 5. But anywhere between 1 to 10 milliseconds is acceptable as a service provider design.
Because in the case of accident or any other thing, if we want to communicate fast, so the first
Absolutely.
heterogeneity and other communication part will first, and then we can deliver whatever the message is there. That's why my question was.
Absolutely right. So for these kind of critical applications, we require a very low latency. But what is realizable through 5G is of the order of 1 millisecond.
Thank you, madam.
Thank you.
Hello, ma'am. Hello, ma'am. Can you hear me?
Yes, sir.
Ma'am, my question is like as you said in 5G we have three verticals. Then what about in 6G? Will also have the same verticals or it will change like in future?
So these verticals are definitely going to be there. But along with that, as I mentioned in the last slide, there is going to be some kind of a new measure which is going to be relevant because of the different kind of applications that 6G has. For example, particular metric, age of information, that is very related to latency, but it is very different. I wouldn't like to get into the details of it, but we expect that not only these three, but there will be more verticals or use cases as far as 6G is concerned, so that we will be able to better deliver in terms of a very wide range of applications.
Okay, ma'am.
Hello, madam. Can you hear me?
Yes, sir.
I want to extend his question with an example. I want if you if we are using it has to satisfy three verticals, right? In a 5G, uh, in present condition, if you tie up with the IoT and with a 5G IoT, for example, if you are considering a vehicle, electrical vehicle, what will be the difference if present scenario and what is the if we use a 5G? Currently we are using a 4G or any different connections, so what will be the
So,
impact?
correct. So, see, as you have rightly picked up a particular application, if we want electric vehicles which want to be, driverless, right? We want, these devices to collaborate and pass on information about its own position in a real time. So there are two aspects to it. One is we are talking about probably say hundreds of vehicles on a highway which are going to communicate with each other. So there is going to be a large inflow of information which requires that the data rates should be sufficiently high to be able to support such a kind of high inflow of information. Second thing is we want things to be done in real time, which means that the delay or latency requirements for such kind of communication to happen should be as low as possible. So with 4G or LTE, the support in terms of peak data rate and latency will not be enough to enable applications like electric vehicles or driverless cars.
Thank you, madam. One more query is there. So
Yes, sir.
how can it helps in a power reduction or a power, how can it saves the power when we use a
So
higher it will consumption, there will be more consumption in the power, so how it can help?
absolutely. So what you are saying is, if we look at the things on a broader level, it gives an impression that all of these technologies are going to be extremely power consumed, right? But one aspect of 5G, as I again mentioned, I think in the penultimate slide, last of one slide, was where we talk about having energy efficient transmission techniques. So there are dedicated research areas, research paradigms in 5G, which talks about simultaneous wireless power transfer, which talks about energy harvesting, wherein, of course, we are going to have definitely some enhanced requirements in terms of power, but with the help of these techniques, we should be able to provide more than what we consume. That's the idea.
Okay, thank you, madam.
Thank you.
Hello, ma'am. One question I have with end-to-end connectivity, because as you said, because security parameters is becoming a bigger issue nowadays. So in case of 5G, how we can tackle it in your view? Can you elaborate it?
Sorry, I couldn't hear the last part of the question, sir. Can you repeat? No. So, as it is, 5G doesn't provide any security advantages. I'm sorry if that was the impression it gave. What we said is 5G IoT in terms of its use cases. For example, if we talk about remote healthcare, the kind of data it handles is very, very sensitive. What we are just trying to draw attention to is that conventionally, none of the aspects of IoT or 5G communication is itself secure in nature, right? And especially for such use cases, one needs to focus on aligning or integrating some kind of security into. So that is not a part of 5G. We need to revisit some kind of, privacy security guaranteeing techniques in traditional, literature to be incorporated along with IoT for it to work.
Okay. Okay. Hello. Hello.
Yes, sir.
Ma'am, according to my understanding, the 6G is right now in a conceptual and research state. And when actually,
Sorry, sir, I cannot hear you.
ma'am, am I right now? Hello?
Yes, sir.
Ma'am, according to my understanding, 6G right now in the research and conceptual state. Right now.
Absolutely.
So when actually it get deployment, how much it will,
When
how much time it will take to get deployed 6G?
Oh,
Uh,
so we expect, the first solid document with respect to the standardization to be released by 3GPP by around 2030. So it will roughly take another 5 years probably for the service providers, telecom service providers, etc., to be able to build infrastructure and put it out in the market. So if you would ask me if I have to give a deadline, it will be at least a decade from now.
okay, ma'am.
Thank you so much, ma'am, for all the valuable insights you have provided.
Thank you very much. Can I leave the meeting?
Yes, ma'am. Okay, ma'am.
Here we wind up the session. Next session will be held in MCA lab at 2:30.
Thank you.
Hello. Everyone is informed that lunch is held at 1:50.